The temperature must have crossed 35 degrees today.
Yeah, let me check.
Hi girls.
Hello, uncle.
It's very hot today, isn't it? It must be 100 degrees.
What was uncle saying? At 100 degrees water boils. We do not have that high temperature.
Uncle is from USA. They use Fahrenheit for measuring temperature. He was referring to that.
Yes, it was mentioned in our book. But I did not know that people were still using it.
Yeah, of course. Let's go home and do an experiment to find a relationship between these two scales.
Experiment? Do we need to go to the lab for that?
Oh no, today is a Sunday. We will do it at home.
All you need for this experiment is a kettle for boiling water, a bowl to pour the water in and allow it to cool down, and a digital thermometer. A digital thermometer has a sensor and a display screen. The sensor has to be dipped in the water or in any other body whose temperature has to be measured. The display panel can show the temperature in degrees Celsius or in degree Fahrenheit. One has to be careful in handling hot water here.
The room temperature is 23.3 degrees Celsius, and this is how you switch it into Fahrenheit.
So 23.3 degrees Celsius is equal to 74.1 degree Fahrenheit.
Yes.
The Fahrenheit scale was introduced by a German physicist, Daniel Gabriel Fahrenheit, in 1724. Actually, he first introduced the mercury thermometer. The Celsius scale was introduced by a Swedish astronomer, Anders Celsius, in 1742.
Are you ready?
Yes. .3 degrees Celsius, 196.2 degree Fahrenheit.
Wait for some time before recording the next temperature.
Didi, you dictate, I'll write.
63.8 degrees Celsius, 146.7 degree Fahrenheit.
The switching should be done quickly to minimize error.
The temperature is dropping slowly now. Shall we put some ice?
Yeah, good idea. I'll get some ice. We should put the ice slowly or else the water will cool down very fast.
If the water cools very fast, it would be difficult to note accurate temperature readings.
Didi, now what shall we do with these readings?
Now we will put them into the computer and plot a graph on it.
Free and open source software Graph 4.2.2 may be used to plot the graph. We can also use a millimeter graph paper to draw a graph with the collected data. You may plot the temperatures in degrees Celsius along the x-axis and those in degrees Fahrenheit along the y-axis. We also need to select the scales in such a way so as to accommodate all the points obtained through the experiment.
75.4 degrees Celsius, 167.5 degree Fahrenheit, 69.1 degree Celsius, 156 degree Fahrenheit, 46.7 degree Celsius, 105.1 degree Fahrenheit.
Okay, let us see.
Best fit line is one that's a mean graph and the points may lie on the line as well as on both sides of the line but very close to it.
The C is 0 on the x-axis and F is 32 on the y-axis.
So that means when it's 0 degree in the Celsius scale, it is 32 degree in the Fahrenheit scale, isn't it?
Yeah, that's right.
The graph tells us that the temperature of melting ice is 32 degrees Fahrenheit. Let us see if it is really so.
Yeah, that's right. And from this graph, we can also derive those Fahrenheit values of which they are not recorded.
Is that so? Well, I haven't recorded 70 degree. What does the graph tell me?
It is 159 degree Fahrenheit.
Okay. And 50 degree?
It's 122 degree Fahrenheit. So, can you tell me what is the Fahrenheit value of 500 degrees Celsius?
500. We do not have that in the graph.
So it is not always convenient to read a temperature either in Fahrenheit or in Celsius from this graph. A suitable relationship between the temperatures in the two scales is more helpful.
So, we have to study the graph and derive the relationship between these two scales of temperature. Let's see what we can do in the graph.
Every point on this graph has an x value and a y value. Let us work with 2 points at a time.
Take my phone and open calculator. 174, 136.9 and 78.9, 58.2. What is it coming?
1.79.
Another time, 167.5, 125.4, 75.4, 51.9.
1.79.
The exact relationship may not come out from this experiment as there are some experimental errors. However, one can see that the relationship between the two temperature scales is linear. The vertical line segment represents the difference between y values of the two chosen points. The horizontal line segment represents the difference between the x values of the two chosen points. The ratio f2 minus f1 divided by c2 minus c1 is 1.8. Their ratio is coming out to be nearly constant for all the pairs of points. The slight difference in the ratio is due to the experimental error that has crept in while recording the temperature. If you work with points on best fitting line, then you will get a nearly constant ratio, that is 1.8, so that f2 minus f1 divided by c2 minus c1 is equal to 1.8.
So, we have got a nice relationship where f2 minus f1 by c2 minus c1 is 1.8.
So f2 minus f1 divided by c2 minus c1 is equal to 1.8. From the graph, we can see that when f1 is equal to 32, c1 is equal to 0. So f2 minus 32 divided by c2 minus 0 is equal to 1.8. So we can conclude that f2 minus 32 is equal to 1.8 c2, isn't it?
That's right. This was the relationship we were looking for. F minus 32 equals to 1.8 C.
Relationship between the two temperature scales can be found out from theoretical consideration, and it comes out to be C by 5 is equal to F minus 32 divided by 9. If temperature is measured in Celsius scale, this relationship enables us to find out the corresponding value in the Fahrenheit scale or vice versa. Temperature of boiling water can be measured to be 100 degrees Celsius at sea level. Let us check it out. The relationship right away gives the same temperature in Fahrenheit scale to be 212. What will be the Fahrenheit value of 1000 degrees Celsius? It will not be 2120 degrees Fahrenheit. If you use the relationship we have discovered, it would come out to be 1832 degrees Fahrenheit. A clinical thermometer, which commonly employs the Fahrenheit scale, reads our normal body temperature to be 98.6 degree Fahrenheit. Its Celsius equivalent is 37 degrees Celsius. Remember, don't mix up the scales.